What's up, guys? Welcome back to the channel. This is another derivative that we need to find. As you can see, this is a natural logarithmic function, so we need to find the derivative of this function here. Now, if it's your first time on this channel watching the videos here, welcome to the channel. I would like to inform you guys that I made videos on trigonometric functions, how to solve them, how to manipulate them, and all that. I also made videos on limits as well. I also made videos on binomial theorem, the expansion, and how to find the specific term. Right, so when it comes to derivatives, I also made the videos on deriving from the first principle. You can go and watch those videos on the playlist section of this channel, and you can also subscribe to the channel because there's a lot of videos that I'm going to do, guys. Right, when it comes to deriving from the standard and then exponent and then the logarithmic function, I made a playlist that is going to appear at the end of this video. So if you want to watch from part 1 until this part here, which is part 24, you can watch that playlist. So it appears at the end of this video. You can click on it, guys. Right, so if you are new, if you are returning, I mean, you know what to do, guys. Pause this and solve this problem, and let's see if you're gonna get the same answer as the one I'm going to get at the end of this video. Right, so let's start. Before you start with this problem, guys, as you can see here, we have the coefficient of x. For the fact that you have the coefficient of x, you need to simplify this one here. So how are you gonna simplify this problem? Right, so let's do it here. So let's say y is equaling to 1 over 4. Right, let's just take this 1 over 4 and then we put a bracket. Remember, this 4 here is the same as 1 over 4 if you take it outside. So we can say natural log 3 multiply, plus natural log x squared. Right, I have to remind you guys, where is this coming from? I'm just gonna write a reminder here. Reminder. Right, remember, guys, the natural log laws. So this is actually a law. There is a law that says when you have natural logs, let's say natural log a plus natural log, let's say b, your answer here is gonna be natural log then a multiplied by b. This is same as logs, guys. Remember, logs and natural logs they have the same laws, guys. They have the same laws. So even with logs, it's gonna be the very same thing, a multiplied by b. So this, what I did here, guys, is exactly that. What happened is I took out the 4 out, and then because we have the coefficient, this 3 is multiplying the x squared. So if you apply the law, you can do this here. I hope you understand, guys, but you can go to your logs or natural logs law and check them out. You'll see this is exactly how you're supposed to do it. Now, with this being done, let's remove the brackets. We can multiply by 1 over 4, meaning we're going to have the first term here now, which is going to be natural log over 4, plus the second term, which is going to be natural log x squared over 4. Then this is it. From here now, we can go to our formulas and check which formula are we going to use to derive this function here. So if you look at our function on our left, it can be a bit complicated. Remember, if there is no x, that term, it means it's 0. Remember, we are deriving in respect to x. So we can say natural log, we do have a coefficient. What is our coefficient? So it's going to be k, that is multiplying our natural log. And then we have x, but then we also have n here. So what is the derivative of this? When you check your formulas, this is gonna be n multiplied by k over x, right? But let's look at this problem here. Let's look at this function here on our left, right? When you look at this, guys, when you look at this function, this one here, this one here, this one here that I'm underlining and grabbing, basically is gonna give us 0. The reason why it's gonna give us 0 is because there is no x here, guys. Okay, there is no x here, so we are deriving in respect to x. So remember, if there is no x, the term is gonna give us 0. I hope you guys understand, because it really needs you to understand that. So what you can do is we can find the k, which is gonna be half 1 over 4, I mean, and then we find the n, which is our exponent, which is gonna be 2. Then from there we just substitute and try to find this. So dy over dx, this is gonna give us, the first term is gonna give us 0 because there is no x. We are differentiating in terms of, or with respect to x. Do not forget that one. That's why this one is 0. Now let's go to the second term. Now the second term, what is our n? Our n is 2 multiplied by k. Our k is 1 over 4 multiplied by our derivative of our natural log, which is going to be 1 over x. So if you continue here, dy over dx, this first term is 0, so we're not going to consider it. So we know that this is 2, and that we're going to be left with half, with 2. So if you say 2 multiplied by 1 over 4, the answer is going to be half. So what's going to happen here? We're going to have 1 over 2, and then the answer is going to be like that, 1 over 2x. So guys, I hope you understood this, because it might confuse you, especially when it comes to this term here, or breaking out this problem here, simplifying it. Remember, you have to know your natural log laws and the standard log laws. Okay, so guys, I hope you understood. If it so happened that you didn't understand, you can watch this video over and over again until you understand, and you can also comment in the comment section and ask a question. Hopefully I'll be able to answer the question. If there's something to add, comment as well. If you manage to find this problem, comment. I would just like to know what you guys think about all these math problems, and then you can share these videos to your friend. And if you haven't subscribed, you can subscribe to the channel. I would really appreciate that. If you want to watch all the videos on derivatives, from standard derivative to this part here, you can click on the playlist that appears at the end of this video. Thank you very much, guys, for watching. I hope you have a wonderful day. Cheers.